Okay, so we're going to back up a little bit and look at how do we find the rate of change from a graph. So to be very specific about how we're going to do that from a graph. So the very first thing you have to do is that you have to find points or an ordered pair. So points are anywhere where our line, let me highlight our line real quick, goes through the grid at corners. So if we're looking at, like this point here, okay, that's not going through a corner. The graphed function is going through just a single side of the rectangle. However, if we move over a little bit, we can see that our graphed function is going through a corner. It's going through 4 corners of the rectangles. So that would be a point, or a point that we would want to use, an integer point. And then if we keep going, we see this one doesn't work, but this one does. So I'm going to go ahead and label all the good or integer points that I see. So for example, this first one we saw, that would be a good point. Over here, this would be a good point. This would be a good point. This would be a good point. Okay, so, and you should already start to see that there's a pattern as where those points appear, where those easily countable points appear. So that's the first thing we're going to do. The next thing we're going to do is we're going to find the rise divided by the run. Okay, so once I look at, I'm going to switch to blue here. Once I have my points, I can pick any 2 of those. So I can pick this one and this one, or this one and this. It doesn't matter. Just pick any 2. For funsies, I'm going to pick this first one and this last one we have noted. So by the rise, I mean how far do I have to climb up to get on the same level as this point? So I have to climb up 1, 2, 3. And then I have to go over 1, 2, 3, 4, 5, 6 spaces. Okay, so we might be tempted to say that my rise over my run is 3 over 6. However, I've really got to pay attention to the axis. So if we look at our x-axis, or sorry, our y-axis here, I see that it's actually going up by tens. So when I go up by 30 or by 3 right here, I'm actually going up by 30. And then to make that a little more difficult, I see that it's actually in thousands. So when I say plus 3, I'm actually going up $30,000. So my rise in this case is going to be $30,000. So now let's look at my run. So I said that my run was going over 6. But if we look again at my x-axis, we're going up by tens here. So when I say I'm going up by 6, I'm actually, or when I say I'm going over by 6, I'm actually going over by 60. So my run is actually going to be 60. So now I can go ahead and reduce that fraction. So I'm going to have 30,000 divided by 60. Remember, when we're reducing by tens, we can kind of cross out that any zeros they have in common. So now I've got 3,000 divided by 6. I'm going to do some quick mental math. I know that 30 divided by 6 is 5. And I've got 2 extra zeros. So I know that my slope, or my rise over run, is actually going to be 500 when I reduce that. So if we think about what that means in terms of the problem, so my rise is 500 for every 1. So that means that for each student, the school is getting $500 in addition. So we're looking at that previous problem in addition to that $100,000 that they get. But my slope, or my rise over my run, would be 500 over 1, or just $500 when it reduces.